Hello friends, myself Ashok Sangre. Today we are going to start the chapter Amines. Now, in this chapter, we have to already see introduction of amines, classification of amines, nomenclature of amines, as well as we have to also see the preparation of amines also. Now, in that preparation of amines, in which we have to already see the three methods. The first method from alkyl halide aminolysis reaction. The second method from alkyl halide gabriel thalamide synthesis, and the third method reduction of oxime, alkyl cyanide, nitro compounds, amides. Okay, in this way we are going to see the preparation of amines by using these three methods. Now the last one, but very important, fourth method, like this as a from amine. From amine. Okay. Now in this reaction it is known as a Hoffmann bromamide degradation. This reaction is known as a Hoffmann bromamide degradation. Now, in this case, when amide is reacted with bromine with alcoholic or aqueous solution of sodium hydroxide to give the primary amide. This reaction is useful to decrease the length of carbon atom or one carbon atom. That's why the reaction it is known as a Hoffmann bromamide degradation. Why? Because this reaction is useful to decreasing the length of carbon chain by one carbon atom. That's why we have to take a general reaction like HAR C double bond O NH2. Okay, this is known as a amide. Is reacted with bromine plus anyway sodium hydroxide like a alcoholic or a aqueous. Now in this case this bromine in sodium hydroxide we have to take here which undergoes heating. Now in this reaction the molecular rearrangement can take place. That means the migration of alkyl or aryl group from carbonyl carbon to the nitrogen atom. That's why the molecular rearrangement is taking place. Now in that molecular rearrangement, the migration of this alkyl or aryl group from this carbonyl carbon is migrated to the nitrogen atom or attached to the nitrogen atom, and then formation of a primary amine. Plus these are the sodium, it also formation of a sodium carbonate and the sodium bromide. Na2CO3 plus 2NaBr. In this way we can balance this reaction. These are the bromine, here also two molecules of bromine, sodium here 4 times. In this case these are the sodium, there are 2 times, and here too there are the 4 times, and this carbonyl group is there CO, and here also CO3. Okay, here Na2 here. How many molecules we have to take here? Now in this case we have to take plus of H2O. These are the remaining here. Uh, in this case, the hydrogen is there 4 times, and oxygen here, here 3 times, and remaining here 5. That means you have to take here. These are the 3, and here 2, 5. Okay, there are 4 times oxygen and 1. That is the 5 times. In this case, we can balance this reaction and can also form a primary amine. Okay, this is a primary amine. Okay, in this way we can form primary amine, and this reaction is very important, and the reaction is known as a Hoffmann bromamide degradation. That means the molecular rearrangement can take place. And now the migration of this alkyl or aryl group from the carbonyl carbon to the attached to the nitrogen atom and can form as a primary amine. Sodium carbonate, sodium bromide, and water molecules. Okay, in this way we can form the primary amine, the molecular rearrangement. Now in that reaction, there is a decreasing the chain length of carbon by one carbon atom. That means there are in that carbon chain there is a one carbon atom there. Now this carbon atom can be decreases and can form as a primary amine. There is no any carbon atom, and in this way, this reaction is useful to decreasing the chain length by one carbon atom. The reaction is a Hoffmann bromamide degradation. That's why when amide is reacting with bromine in alcoholic or aqueous solution of sodium hydroxide undergoing to do the primary amine. Okay, it is the general reaction. Now we have to take here example. Now in this case we have to take the example like there is a propanamide. Okay, now in that reaction CH3 CH2 C double bond O NH2. This is known as a 1, 2, 3. That's why propanamide. 3 carbon. Propane is replaced by amide. Propanamide is reacted with bromine in aqueous or alcoholic solution of sodium hydroxide, which undergoes heating to give the corresponding product. Now this alkyl group can be migrated and is attached to the nitrogen atom. And then formation of like this, the product like this CH3, CH2, NH2. This is known as a ethanamide. This is known as a ethanamide, and can also form similar ways formation of Na2CO3 plus 2NaBr plus H2O. In this way we can balance this reaction. Now in this reactor, in this case there are the 3 carbon atoms here in that chain. But now by the molecular rearrangement can take place and can formation of only 2 carbon atoms there. That's why with decreasing the chain length by 1 carbon atom, that's why the reaction is a Hoffmann bromamide degradation. Degradation is take place here. Now another one more example we have to take here benzamide. Okay, like this we have to take here the C double bond O NH2. Okay, benzamide is reacted with bromine plus sodium hydroxide in alcoholic or aqueous medium. In this case, this aryl group can be migrated to the nitrogen atom, attached to the nitrogen atom, can form a primary amine, and the primary amine is named as aniline. Okay, this is a aniline plus sodium carbonate plus sodium bromide plus H2O. In this way, we can balance this reaction. The reaction it is known as a Hoffmann bromamide degradation. That's why the primary amine can form from the amide. Okay, in this way, we can complete the preparation of amines by different methods. The first method from alkyl halide ammonolysis reaction. Second method from alkyl halide Gabriel phthalimide synthesis. The third method reduction by oxime by alkyl cyanide amide as well as the nitro compound. And last method from amide Hoffmann bromamide degradation. In this way we can complete the preparation of amines. Okay. Then now we can see the physical properties of amines. Now the physical properties of amines. You know the physical properties of amines in which the lower members of primary amine are gaseous, and also aliphatic amines is the gaseous. The amine which has 3 or more carbon atom, it is a liquid in state, and the higher amines which has a solid state. Okay. Now in this case the aryl amine are a very toxic in nature. Now in aliphatic amine, that is the primary amine, secondary amine, it can be soluble in the water, can form as a hydrogen bonding with the water molecules. That's why it can soluble in the water. Now this is the also in this case we can also see the primary amine, secondary amine, it undergoes intermolecular hydrogen bonding take place. But now in the tertiary amine, it cannot form the hydrogen bonding or intermolecular hydrogen bonding. Sorry. Okay, intermolecular hydrogen bonding cannot take place in the tertiary amine because the absence of hydrogen atom. Okay, in this way we can see the physical properties of amines. Now we can revise once again. The first, the aliphatic amine, lower member of aliphatic amines are gaseous. The amine which has 3 or more carbon atom which has a liquid in state, and higher amines or higher ones are the solid in state. The amines can form as a hydrogen